an hour. I'm back outside recording the weather as there's now another band of rain coming in. Okay. So now it's back. Another heavy downpour is back, and look what's coming in right now. There's a pretty heavy shower coming in right now. Yeah, I'm looking down the street, and there's some moderate to heavy rain coming in right now. Well, moderate rain, not heavy, moderate. And yep, there is yellows on radar, so I actually thought initially that this was going to go to our north. And there's no grapple with this, just rain. See, there's definitely convection with this activity here. So the sky does look kind of scary. Looks a little menacing, especially looking over here. You can see a wall of gray. That usually means there's about to be a thunderstorm. See, it's only lightly raining at the time. I mean, at the moment. Now there's some bit of a breeze coming in, probably because of the downdraft. Now it's raining a little harder. We're just getting light rain right now. Ugh, yeah, it's definitely raining moderately right now. Yep. Oh my God, we're getting moderate to heavy rain right now. Oh my gosh. And now we're getting a downpour. Woo! Now it's pouring. See, that's where the rain's coming out of. Any grapple? Let's see. Because the drops are getting kind of big right now. No grapple, just big drops of rain. Yep, I don't see any residue of ice being lingered on the car, so yeah. Let's see. See those striations? Definitely there was some snow coming out of those base of those clouds. Look at all the water coming out of the car, dripping off the car. I had a feeling this is going to happen. That's why I came out. I'm going to check the radar right now. Yep. Yeah, we're right in the thick of it, guys. Yeah, we're right in the thick of this shower here. Also, this probably produced, I don't know, 1 millimeter of rain. Maybe 100th of an inch of rain. 1 to 500th of an inch, probably. Maybe up to a 10th of an inch. Because, there's already some small puddles being formed by this shower. I mean, this is about the second or third, like the third shower that passed through this area. And the clouds are coming in from the northwest. So they're like... And we were definitely in the thick of this downpour. Because as I'm looking, you see this wall of gray over there. Remember, as I said, that the wall of gray was passing right over me? Well, the downpour came from this section right here. But of course, the base of the clouds, it's all snow, basically. You see how small the drops are now? Now they're really, really small and fine. That's indicative that there is some snow coming out of the base of these clouds. I've seen this when it was marginally warm enough for snow. The visibility does look kind of bad over there. That's because, I mean, look how the sky looks. The sky definitely looks like it's snowing. Like, that's how the sky looks like when it's snowing outside. This is very typical on a day that has a lot of cold air loft, that has the freezing level being very low to the ground. But of course, there is no ice coming down. It's all rain. But there was graupel earlier when there was more convection. There was this convective cell that produced some graupel earlier. And I witnessed it myself. But the way the sky looks now, after this downpour passed through, it definitely is basically indicative of cold air loft. The freezing level is about 4,000 feet, 3,000 to 4,000 feet. And of course, in Massachusetts, it's even lower because that's where the core of the cold air is. And that's what just passed through. And yeah, it definitely looks like it was snowing out of this cloud. The way the sky looks, like the shade of gray, is very typical of like a snow. If you just had a passing snow shower, the sky doesn't usually look like this on a rainy day. You see how hazy it looks? Usually, if it was a rain cloud, you'd be able to see the outline of everything, but you don't over there. I mean, so it was snow coming out. I wouldn't be surprised if the top of the buildings it was mostly snow, because it's upper 40s here, ground level. At the top of the buildings, it's in the low 40s. The reason it's so warm right now, despite cold air loft or all this cold air in place, is because of all the the April sunshine. I mean, it could snow at this time of year, especially if there's enough cold air in place. This cold air is not very strong. Of course, if the cold air was stronger, this was a more potent cold air pattern. Keep in mind that last year, it snowed in May. I mean, this little shower produced enough water that there's actually water dripping off the trees right now. You can actually hear the water falling off of the trees if you look closely. Those bigger drops you're seeing, it's water falling off the trees. See some of those bigger drops? Plop. Oh, one just hit. Oh, look at that. One of the drops just from the tree hit me. I mean, the sky definitely looks icy today. Definitely looks like the air is very cold today aloft. There is a lot of snow falling from these clouds. This is definitely not rain. I mean, falling as snow. It's falling as rain. Wow, there wasn't a puddle there earlier. Looks like this shower just formed a puddle. Yep. This is from just now. This puddle was not there earlier, so it looks like we got enough precip to form a small puddle. Surprisingly, I mean, these cold air aloft showers are pretty intense, actually. Produce a good little soaking rain. Of course, the dew point is in the 30s, though. I'm gonna look at the radar again. Well, there's more downpours coming in. There are more moderate showers coming in from the northwest. There's actually another similar sized shower coming in my direction, so looks like it's gonna rain again in a few minutes. This shower that just came down was courtesy of cold air loft. You know, instability. And even though these clouds look like they're cirrus, they're actually pretty low. See parts of the tops of these cumulus already being covered. These clouds are like, what, 5 to 10,000 feet up? See? Look at all this water. All this is rain here at ground level. Let me look at the at Upton. I'm going to tell you how high the freezing level is right now. Yeah, basically anything above 2,000 feet, it's primarily snow. Like I checked at 3,000 feet, it's already into the all snow category. About 2,000 feet is where it's like 2,500 feet is where it transitions to all snow. Let me check again. I'm using the tilt right now. If you're at the top of it, you'll be getting a mixed right now. And if you were on the top of the skyscrapers right now, you would be getting a wintry mix. The base of the mix, where it transitions to all rain, is right around 1,000 to 1,200 feet. So yeah, it's definitely pretty low. The freezing level is definitely pretty low. Anything above 2,500 feet, it's all basically snow. I mean, the radar beam, where the radar beam is passing through above us, about 3,500 feet, it's all snow. At 3,000 feet, it's all snow. Even 2,800 feet, it's all snow. So the top of the Burj Khalifa would actually be snowing right now. There was a building that tall. And there's another heavier shower coming in, which is why you could see the dark gray sky over there. Let me look at the radar one more time. I mean, this shower definitely sapped some of the instability away. So I wouldn't be surprised if the shower weakens. I mean, the one that's heading our way. It's probably going to weaken significantly. There it is. I thought it briefly stopped raining. Now it's starting to sprinkle again. You see some of the spritzes there? We just had a heavy downpour that came over like 5-10 minutes ago. Cloud that just passed over is down there. Still, yeah, it's starting to rain again. The freezing level is right around 2,500 feet. Well, that's where, not the freezing level, that's where the snow starts melting. The melting starts right around a little bit above 2,500 feet. That's probably where the temperatures are in the mid-30s. Here at ground level, it's in the upper 40s right now. It was in the 50s earlier, but this heavy downpour kind of cooled down the atmosphere a little. And it got a little windy too, just before the downpour came in. See, it's raining again. So the downpour that just came over us is now passing, or basically approaching right on top of Freeport, Long Island. It's about 10 miles away. So see. Yeah, we just had a pretty good soaking rain here. Some of the puddles are new, some of them are not. You can actually hear some of the water coming off of the gutters a little bit. And there's another good soaking downpour coming in right now. See, the trees are pretty wet. This year we got a pretty good amount of snow, definitely more than the last couple of years. We actually got more snow this year than the last 2 years combined. It's pretty impressive, actually. And there's still the possibility of even more snow, possibly in like 10 days if the European model is actually correct. So basically, now that COVID is basically being defeated, the U.S. economy is, and in fact the world's economy is going to have a big rebound. And this rebound needs to be very careful. We need to make sure that this new rebound is powered by renewable energy and not powered by fossil fuels. So as an environmentalist, I support sensible energy. For example, not all nuclear energy is sensible. For example, every single nuclear reactor that is in operation today is a ticking time bomb. Every single one of them. I don't mean like a few of them. I mean all of nuclear reactors today are ticking time bombs for one reason only. They all use water for pressurization and coolant. You need water to pressurize the reactor to turn the turbines efficiently because the reactors aren't hot enough to, on their own, turn the turbines efficiently. Then you need backups to keep the reactor cool. You need backups for those backups. You know, you need a diesel generator to keep the water flowing into the reactor in the event of a power outage. You need backups for those diesel generators too. And you know what happened in Fukushima? The tsunami came and knocked all those diesel generators out, leaving the reactors unprotected because the water got too hot. It got so hot, in fact, that the hydrogen started separating from the oxygen. And guess what happened? You had a hydrogen explosion and you had a meltdown when all the water drained out of the reactors. That is a problem with nuclear energy today. Am I against nuclear energy fully? No. There's a different way of doing it that's far safer. And I ain't talking about fusion. I am talking about a molten salt reactor, the liquid fluoride thorium reactor, in a matter of fact. The LFTR reactor is the safest alternative to nuclear energy. It's better than the traveling wave reactor because while that reactor is meltdown proof as well, it does not consume waste. In fact, it consumes everything. And then you have to bury that. And you have to dispose of it. Not a good, sensible solution. Better solution is the liquid fluoride thorium reactor because it consumes almost all of the products it produces. For example, americium, curium, plutonium. The plutonium that is found in the liquid fluoride thorium reactor is not weapons grade. You cannot detonate it in a nuclear bomb. You cannot. It's proliferation proof. If all reactors today were LFTRs, you wouldn't have had Fukushima. You wouldn't have had Chernobyl. In fact, even 3 Mile Island would have not had any issues. It would have been simply a normal day on all these reactors. You won't need a diesel generator for any of those reactors. If power's lost to the reactor, you know what happens? The reaction stops. Simple as that. And it's going to cool down on its own. And not only that, but there is a piece of cool gas that's blown on a piece of salt, that's kept frozen by that cool gas. And that would have stopped the frozen plug would have melted, the sodium would have melted because, it would have caught up to the reactor's average temperature. And so it would have mixed with the other salts in the reactor, and it would have drained into a separate containment tank with no human intervention whatsoever. And guess what? This reactor consumes 99.9% of its byproducts. And that 0.1% that's left over is extremely valuable. For example, bismuth-213, needed for fighting cancer therapy, for fighting leukemia-type cancers, fighting dispersed cancers. Plutonium-239, which is needed for operation of space batteries. Plutonium-238 is the bomb, is the one that's used in nuclear bombs. Well, 239 is the one that is used in space rovers. Actually, it's 238. My bad, 238. And it's the plutonium-238 that is needed. So plutonium-238 is what is needed for deep space exploration to power rovers for their operation. And it produces 238. And guess what? There's nowhere in the world right now produces plutonium-238. Bismuth-213 has a half-life of 45 minutes, so it's extremely radioactive. But here's the kicker: it only decays once, and it's an alpha particle. It's not a dangerous beta particle, which decays multiple times and causes irreversible cellular damage. For example, bismuth-213, well, bodily damage. My bad. Bismuth-213 only decays once, which means once a cell with bismuth-213 attached to it attaches to a cancer cell, and that one decay will kill that cancer cell, and boom, that cell is gone, and you're not destroying other nearby cells. It's basically like a guided missile. Instead of carpet bombing everything out of existence, you're using a guided missile to only destroy that one target with no casualties, no other casualties. That's bismuth-213. And of course, it's extremely difficult to produce, and it's incredibly rare because bismuth-213 only formed when the universe was created. There is no natural bismuth-213. There is no natural bismuth-213 in existence anywhere right now. All bismuth-213, if there is anywhere, is only produced by man. And also, molten salt reactors, as I said, don't only consume their own waste, they can consume our nuclear waste that we've produced by today's reactors. And instead of burying them for thousands and thousands of years, where they'll continue to pose hazards for the rest of basically their life, just use them as energy. Don't bury them and have them lying around for someone to stumble upon and get really sick from it, or release it into the environment, God forbid. Today's nuclear energy is extremely dangerous. I mean, of course, here's the thing. You think nuclear energy is dangerous, right? It is. Don't get me wrong. The way we're doing it today is really inefficient. It's not, the safest. The thing is, fossil fuel plants, coal, emits more radioactivity than all the nuclear plants. One coal-fired power plant releases more radioactivity into the atmosphere than all nuclear plants combined. Because coal is in the ground. And guess what you have in the ground? Radium, thorium, uranium. You have radon. And all that radioactivity, natural radioactivity that seeps into the ground. And when you frack, you release a lot of radon into the atmosphere. If the Nuclear Regulatory Commission was aware of how much, or regulated coal power plants, you wouldn't have coal being used, or natural gas, because guess what? They emit more radioactivity than nuclear plants. The amount of radioactivity that they release every day, just one plant, would be considered an accident at a nuclear power plant, just for your information. And here's the thing. These plants are not only, causing radiation, the Earth to become more radiated. But here's something even worse than anything. Mercury poisoning. Do you know why it's unsafe to eat fish, especially tuna? Because of coal. Coal is the main culprit. And here's the thing about renewable energy. It's great, especially if you use it on your house. You have a offshore wind farm, great. But what about when you have to cut down hundreds of millions of trees to put in a solar plant or to put in wind farms, or to put in a natural gas plant, which also releases radioactivity through its operation, especially fracking. God forbid. Oh my God, fracking is so bad for the environment. And here, you know what I think of fossil fuels? I think of fossil fuels as the worst. Fossil fuels are the worst. They, cause radiation to go everywhere, the climate change. And while today's nuclear energy is better, it's definitely not what it should be. We should not be having the type of reactors we have now. We should be having Generation 4 molten salt and liquid fluoride thorium reactors. We should have honestly started building them in the 70s, because there was an Oak Ridge National Laboratory molten salt reactor experiment that was a lifter. It was an LFTR. It was a liquid fluoride thorium reactor. Had no incidents in its entire operating history. Nothing happened. And you know why it wasn't used? Guess who axed the program? Nixon. Reagan tried to restart it, but basically it never gained any ground because the military-industrial complex wouldn't let it, basically. The lobbyists for the more nukes wanted, the traditional reactors that we use today, because they supplied the plutonium and the uranium needed to build nuclear bombs. Atomic bombs, nuclear and atomic bombs. That's all they needed. Now we don't need bombs. What we need to do is we need to get our asses off the chair and start finding a solution to climate change, something Republicans really do not want to do. And then you're having some environmentalists who are really concerned about climate change, as I am, but they're not looking for feasible solutions to say, we need to only use renewable energy. Renewable energy is just as destructive to the environment, because you need to cut down a vast swath of land and to produce much less energy. And here's the thing. You don't have to open new mines to get thorium. Thorium is one of the most common elements in the earth. It is as common as lead. And yet the nuclear energy we're burning today is as rare as platinum. Yeah, can you imagine burning platinum for energy? Just to quote one really brilliant scientist, Kirk Sorensen, he said, can you imagine burning platinum for energy? And he goes on to say, that's what we're doing with our nuclear energy today. It's not, and he says, and then he went on to say, we're burning this extremely rare stuff, but we're not burning thorium. Thorium is the key to our energy future, and eventually fusion. But that's decades, perhaps even centuries away, because fusion is basically, it's impossible to achieve fusion right now. Sustained fusion especially. And they're spending so much money building fusion. Oh, let's do fusion. Do you know what's truly renewable? Sustainable? Thorium. Because thorium is found everywhere. It's on the moon, it's on Mars, it's on every rocky body in the solar system. Thorium is one of the most common elements in the universe. You'll basically never run out of it because it's just too common. It's everywhere. And of course, holding a piece of pure thorium in your pocket won't get you sick. Because thorium in itself has a half-life of 4 billion years? You know what that means, right? It's not radioactive. The longer the half-life, the less radioactive it is. The uranium we use today has a half-life of maybe 10 million years, so it's pretty radioactive. It's like a few 100,000 years. So it's pretty hot. Molten salt reactors. Here's the thing about thorium. While thorium itself is not very, very radioactive, it has a huge energy potential. It's locked up in the thorium, so it's not radioactive in itself. But once you hit it with a proton, it absorbs the proton and then releases 2 neutrons, and then it basically starts a chain reaction in the reactor, which will eventually turn the thorium into uranium-233 over a course of a month. So first it's going to be thorium-232, then it'll become thorium-233. Thorium-233, very, very radioactive. You do not want to touch that stuff. It's really dangerous. Thorium-233 becomes americium-233. Americium-233 will become thorium-233 in 1 month. Americium-233 has a half-life of 1 month. And then you could use that for energy. And it's all in the same reactor, basically, like a separate area in a reactor, like not in the where all the energy takes place, but like thorium is it's a breeder reactor, which means you have to breed the thorium into uranium. You don't have to refine it. There is no refining. You don't refine the thorium. You just turn it into uranium, and that's it. And then you just fission it, and then you just fission the uranium down its decay chain, that down the thorium-232 decay chain, and whatever's left over, it's really little, and it's actually useful. All of it is useful. You don't have this useless waste products that has no purpose, basically, like what we do today with our nuclear energy. That's a Boeing 767. That's a Delta 767. So we're about to get a moderate shower. And this is not the last one either. Looks like it's not going to be as heavy as what just came over us a few moments ago, or like 20 minutes ago. But it's going to get a little heavier now. There's more stuff coming in from New Jersey again. But I think it'll probably pass us just to the north and east. Let me look at the radar again. Well, here comes the rain now. Well, here comes the light and the moderate rain again. And there's a pretty heavy shower just to my west. I mean, east, actually. So moderate shower there. And there's a heavy downpour I just saw on radar that is west, just west of me. And by the way, this didn't look that impressive on radar. But it is raining pretty good clip right now. There's a little bit of a breeze with the shower too. But I think this is about as heavy as it's going to get. And there's some more moderate rain in New Jersey that's probably going to pass to our north because it's kind of arcing like this. It's kind of having more of a westward trajectory as the storm pulls away to the north and east. Actually, you could actually see some of the water splashing. Yeah, the rain's a little more moderate now. So we're having moderate rain right now. You can just see some of the striations. Oh, sorry, let me zoom out. See some of the striations here. That's probably all snow up there. And there's actually some convective clouds you can actually see right there. So these clouds, it's basically a mixed cloud. So there is stratus, there's stratonimbus, and there's some cumulus in the distance. So it's a mixed sky right now here in Queens. That is stratonimbus. That's stratonimbus right over there. So let me look at the radar one more time. So yeah, now it's drizzling again. So yeah, I'm gonna put on emping that it's raining outside right now. Thanks for watching, everyone. Bye. So yeah.